Hello everyone, welcome back to our channel. Let's discuss the fragmentation procedure of aldehydes, ketones, acids, esters and amides. Okay, so let's start the video with aldehydes. In case of aldehydes, what is the general formula? RC double bond OH. If we want to create a molecular ion, we will create in this way or not? So in case of these kind of molecular ions, what kind of fragmentation pathways are possible? Let us see. The first one is the what? 2 times we can do the alpha homolysis. See this one, with respect to this one, this is alpha bond and this is alpha bond. So we can do homolysis at alpha bond 2 times. Right side and left side. The same type of thing takes place in case of heterolytic cleavage also. So 2 times we are going to have heterolytic cleavage of these 2 bonds. If the aldehyde chain containing gamma CH protons, what can we do? We can observe McLafferty fragmentation. So these are the 3 types of rules which we need to follow for the fragmentation of aldehydes. So let us see the different kinds of the cleavages in aldehydes. The first one is the what? This is the general aldehyde having the molecular ion at oxygen. So what is the first one? We need to do 2 times alpha homolysis. So see this one, if you do the alpha homolysis, what is happening? We will come up with H radical and C radical. So H radical will be removed and we will come up here with a radical or not. So this radical and this radical can form a triple bond. This ion is going to be appeared in the mass spectra. The second kind of alpha homolysis is at the carbon-carbon bond. If you do this kind of cleavage, what is happening? The R radical will be removed and you will have C radical. These 2 radicals can form a pi bond and we will come up with this kind of ion. Okay. So second type is what? Alpha heterolysis. 2 times alpha heterolysis. See this one. The first case is this is alpha bond. This one is also alpha bond. What we are doing? Heterolysis phenomena we are doing. Here R is removed in the form of R plus. This peak will appear in the mass spectra. During the heterolytic cleavage, see this, what is happening? We are giving negative charge to the carbon or not? Already positive charge is present. This negative and positive can form a triple bond. Thereby we will come up with the radical. So radical can be removed. Next type, if you do the alpha heterolysis at this bond, what is happening? The H is removed in the form of H plus. So the M by Z of H plus is going to be appeared in the mass spectra. So because of this reason, see this one, the carbon is getting the negative charge. This positive and negative can form a triple bond. Then oxygen is coming up with what? Radical. This radical will be removed. Here is the example for the McLafferty aldehyde containing alpha, beta, gamma, CH function. Thereby we are observing the McLafferty fragmentation. This ion is going to be appeared in the mass spectra. So these are the common rules for the fragmentation procedure of aldehydes. The similar kind of situation is going to appear in ketones also. See this one, 2 alpha homolysis, 2 alpha heterolysis and McLafferty fragmentation. So what is the difference between the aldehyde and ketone? Here the H is replaced with what? Some R group. That is commonly called as ketone. So simply do alpha homolysis 2 times, alpha heterolysis 2 times. Then if ketone is having the gamma CH function, do the McLafferty fragmentation also. Okay. In case of the ketones, if the ketone is having this kind of situation, alpha, beta, gamma. Gamma position having hydrogen, alpha, beta, gamma position having hydrogen. If the ketone is containing 2 gamma CH functions, we will observe 2 times McLafferty, that is commonly called as a double McLafferty rearrangement. Already we had a discussion in the previous videos regarding the McLafferty rearrangement. So there is a possibility in ketones that the double McLafferty rearrangement along with these alpha homolysis, alpha heterolysis and the simple McLafferty. Okay, now come to the next one, the fragmentation procedure of acids. What is the general formula of acids? RCOOH or not? So what are the main peaks? M minus OH, M minus COOH, COOH plus and McLafferty. 4 types of ions we will observe during the fragmentation of acids. See this one? This is the general representation of the molecular ion of carboxylic acids. The first one is the what? Removal of OH. OH should be removed in the form of radical. So it is alpha homolysis. OH radical removed. So carbon is getting radical. These 2 radicals can form a pi bond. So RC triple bond O plus. This ion will appear in the mass spectra. Similarly, the alpha heterolysis. We need to remove COOH or not. For that purpose, what we are using? Alpha heterolysis. So thereby what we are getting? R plus ion or not? The R plus ion will appear in the mass spectra. Here we are giving C minus. Already plus is there. The plus and minus can form a triple bond. And you will come up with what? Radical. Okay. The next one is second alpha homolysis. If this bond is subjected to homolytic cleavage, what is happening? The R radical will be removed and here we will get the radical. Okay, these 2 radicals can form a pi bond, thereby you will come up with this kind of ion. If carboxylic acid containing the gamma CH function, what can we observe? McLafferty rearrangement. Okay. In case of esters, similar to the acid. So what is the difference between the ester and acid? The carboxylic acid is COOH. If the hydrogen is replaced with some R, then that is commonly called as what? RCOOR. Ester or not? So here H is replaced with R, here H is replaced with R, here H is replaced with R. So these ions will be appeared. If the ester containing the gamma CH, we will observe what? McLafferty. So similar kind of situation, see this one. M minus OR, M minus COOR, COOR plus McLafferty rearrangement, double McLafferty rearrangement and loss of ketene. This is the additional thing which we are going to observe. In case of the esters, loss of ketenes and also double McLafferty. See this one. In case of the ester, the situation may be like this for the McLafferty. The situation may be like this. Here O is present, here C is present. In both the cases, we are observing 2 different peaks. So 2 times McLafferty we can do in case of the ester. Okay. The last one is what? Loss of ketene. How to remove the ketene from the ester? See this particular example. PH CH2 O C double bond O CH3. Here molecular ion is formed. We need to remove what? Ketene. What is the general representation of the ketene? This one is or not? CH2 double bond C double bond O. How can it be removed? By the homolytic cleavage of this bond and this CH bond. See this one, what is happening? The homolytic cleavage of this bond is offering what? 2 radicals or not? The homolytic cleavage of CH is offering what? 2 radicals or not? So these 2 radicals can form a single bond. PH CH2 OH plus radical. This peak will appear in the mass spectra and CH2 radical C double bond O. So these 2 radicals can form a pi bond. Thereby you will come up with ketene CH2 double bond C double bond. So in this way we need to observe the fragmentation procedure in case of esters. So what is the last type in this particular video? Amides fragmentation. The general formula of amide is what? RC double bond O NH2. So similar to acid, in case of acid OH, here NH2. COOH, CONH2, COOH plus, CONH2 plus, McLafferty. So what is the additional one? Cyclization phenomena is additional one in case of the amines. See the first type, we need to remove NH2. This is the molecular ion. For that purpose, what we are doing? Heterolytic cleavage we are doing. In case of heterolytic cleavage, what is happening? These bonding electrons move towards the nitrogen. So the nitrogen will take minus charge or not. So the carbon will get the positive charge. This peak will appear in the mass spectra. The second one is the what? Removal of CONH2. So this one is subjected to alpha heterolysis. So you will come up with R plus ion. This peak will appear in the mass spectra. CO double bond NH2 will be removed. Next type of alpha homolysis at this position is creating what? R radical or not? So here we are getting one radical. This radical and this radical can form a pi bond. Thereby you will come up with this kind of ion. That will appear in the mass spectra. If the amide is containing gamma CH function, we will observe what? McLafferty rearrangement. Along with these common type of fragmentation methods, if the amide containing long chain carbon atom, what we will observe? Cyclization phenomena. See this one? This is the amide containing alpha, beta, gamma and delta bond. At delta, what is happening? Homolytic cleavage takes place. Thereby, R is removed in the form of R radical. So here we are creating a radical or not? So this radical and this radical can form a single bond. Thereby you are coming up with a cyclic cation. The cyclic cation will appear in the mass spectra. Okay. The cyclization phenomena not only takes place in case of the amides containing the long chain carbon atoms, it can also take place in case of ethers, halo compounds and amines along with amides. So this is all about the fragmentation procedure of aldehydes, ketones, acids, esters and amides.